This is John Wilson at MDS. Today we're going to make a video on setting up test plans, specifically the resistance part of the test. So as you see on the screen here, we have the normal Windows desktop. I'll start the MTC2 software. We'll get a nice screen that shows key information on the tester. And there's our self-test. And finally, it asks us to see if our test leads are in good condition, and they are. It opens up the test plan that was there when we last shut it down. But what we're going to do today is make a completely new test plan and add the resistance test to it. So the first thing to do is in this upper right-hand corner, you unlock the programming mode. And then we'll come over here to our Set Values menu and select New Set Values. So we are going to make a new sequence, and we're not going to copy the old one. So as you can see here, we have a blank test plan. There's nothing in it. No high-pot test, no resistance test, no surge test. So let's add a surge test. So we go to the Set Values menu, come over here to Resistance Test, and press the button. Here we're given the setup screen for resistance tests, and I'm going to give this particular step a name, and I'll call it resistance 1 to 2. I'll give it test lead 1 for the first test lead, and then test lead 2 for the second test lead. Now, as you can see, we've got 4 test leads here. We can use them any way we like. The next item here is to do temperature compensation using copper winding. There's a couple other choices, PT100 thermistors, thermocouples, and whatever. But what we're going to do is do copper windings. The mode we're going to use is resistance. The other options are to do a deviation or some sort of contact resistance measurement. For now, we're going to do a resistance measurement. We'll keep that one there. And now we have an opportunity to put in the resistance of whatever we're testing. Now, in this case, we're making a generic test plan. We don't know what the resistance is. So we're just going to give it a number just so it has something to be happy with. And you can see here that it's given a tolerance based on the plus or minus percentage here. We can change this if we like. That's okay. It'll automatically calculate it. But we'll just accept it at 5%. Now, down here at the bottom, what we want to do is go through 3 resistances, do a deviation calculation, and then based on that deviation calculation, pass or fail the test. What we don't want to do in this step is cancel it if it's not good. And by good, it would be 1 ohm plus or minus 5%. So let's not cancel it. And we also don't want to make any conclusions based on this test, whether it's 1 ohm or not. So let's check this box that says this test won't be rated in reference to the set values. So let's talk about set values. Set values are these things here, the resistances that we have and the pass-fail criteria that we have. So that's what set values means. So let's check this box, and we'll say OK. Now we have our first resistance step. Since we're making a test for a 3-phase motor with 3 terminals, we need 2 more resistance measurements. To get that, what I'm going to do is copy the one that we've already got, and I'll insert it twice. There's the first time. Now to get this menu that you see here, I am right mouse button clicking and going to insert. Now to edit one of these new test steps, I can double click with the left mouse button like this, or I can right mouse button click and select edit. Here we're going to do leads 2 to 3, and I'll change my name to make sure that I keep everything straight. Now this name up here can be anything you like. You can type in something very specific to what you're doing. I would suggest you put something in there that helps you understand or remember what you set up this particular test step to be. Now, we could leave this screen and go back to the main screen to pick up this one and edit it, or let's go back to the second step. We can use these up-down arrow keys that will sequence through the different steps. Let's use that one. Let's use the down arrow key to get to the next step. Now you can tell that you're on step 3 because up here in the top of the window it says step 3. Here we want to do 3 to 1. Just like that. And we'll rename the test step. So now we've got our 3 measurements here, but what we really want to do is make those measurements and compare them to each other and calculate a deviation. So the way to do that is to grab any one of your test steps you've already done, make a copy of it, and then insert it again. So now we've got 2 3-to-1 resistances. We'll modify the one on the bottom to be a deviation calculation. So I'll edit this one, and I'll change the mode from making resistance measurements to calculating a deviation. And you can see the screen changes a whole bunch. Pass-fail criteria for deviation calculation is per whatever organization standards you want to use. I'll use 5%. And I'll change the name so that we understand what we're doing in this step. And there we go. We've got a resistance calculation done. And if we look at this, we now have 4 resistance steps. Let's take a look at this again. We've got some options down here. Cancel a test if this step is not good. So if our resistance measurements are outside of 5% and we have this checked, the whole test would stop. We don't want to do that. We want to continue to go through all of our tests because let's say we have a bad resistance reading, most likely one of the other tests, an isolation test, a megohm test, or a surge test will also confirm that measurement. So I'm not going to cancel anything here, but I do want to rate it. I want to make the comparison between our calculation and these set value of 5%. So there we go. Let's just run this thing, see how it works. I'll explain this work order screen here later. For now, we'll just do a test without an order, which really means work order. There you go. Passed. So if we look at this again, we've got our resistance measurements there, and we got 0.178% difference in these measurements. So there's one thing I'd like to do, go back and make a change here. On this screen, we noticed we had a stabilization time of 0 seconds, and that's why it ran through that resistance measurement so quickly. To make this test plan more generic, so it will do high inductance coils, low inductance coils, any coil, I'm going to give it a stabilization time of 1 second. That will give the system plenty of time to stabilize in a very good and accurate reading. Now I'll do that to the other 3 steps. And there we go. So now we've got, it'll run a little slower, but we're guaranteed that this test plan will work for any stator that we come up to, even very high inductance stators. So now we've got the beginning of our test plan. It doesn't have a name yet. Let's give it a name. So save set values as, and I'll give it a name here, and I'll call it example test plan. And say OK. You can see down here in the lower left-hand corner, we've got a name for this particular test plan. And so there we are. We've set the machine up for a resistance test.